Hey everyone, Miss Pipel here. In this video, we're going to be talking about isotopes and specifically isotope notation. So in our in-class activity, we reviewed the atomic structure to remind us that atoms are made up of three particles. The ones on the outside are those electrons. We have protons and neutrons, which are both located in the nucleus of the atom, right? That's where most of the mass comes from when we're talking about an atom. And our electrons are actually probably the most important piece or subatomic particle, as we could call it, based on it gives an element all of its properties and lots of different things. So the next half of this unit, we're going to talk about electrons only. So we're going to be talking about all three of those in this video today. Okay, so there are a couple of properties that are important when we're talking about a specific atom. So we are talking about, for this whole part of the unit, for the most part, a specific atom. So the first of those is the atomic number. So this is the whole number on the periodic table that we can see circled here. So for example, nitrogen is number 7, so its atomic number is 7. This is the number of protons in that atom. So what that means is it's kind of like our way to identify a specific element. So any atom that has 7 protons in it is going to be nitrogen. Okay? Any atom that has 6 protons in it is going to be carbon, and so on. The periodic table is ordered in numerical order for atomic number. So that's where you can find that. It's the whole number on the top of the periodic table. The second is the mass number. Okay, this again, we need to remember we're talking about specific atoms. So it's really kind of one atom at a time that we're thinking about this. So the mass number for one atom is the number of protons plus the number of neutrons. Okay, so protons plus neutrons will give you your mass. And the unit we use for that is AMU, which is known as the atomic mass unit. Okay, super easy because the actual mass in grams of those protons and neutrons is so itty bitty and so tiny. It's kind of hard for our brain to process, and so scientists came up with a new unit called the atomic mass unit that allows one proton and one neutron to each be one atomic mass unit. So we just add them together and get our mass in AMU. Very simple. So what we looked at today with the egg activity in class is a vocabulary word called an isotope. So an isotope is essentially different versions of one atom, or one element, we should say. So many elements have lots of different isotopes in nature. You may have heard of, for example, carbon-13 is an isotope of carbon. So what exactly is an isotope? These are atoms of the same element, so we're talking the same element that have different masses. Okay, their masses are what is unique about them. So if we have an element or an atom of a certain element, okay, remember that the protons are what will tell you what element you're talking about. So your protons have to be the same in your isotopes because you're talking about that same element. Okay, well, remember too that our mass is equal to protons plus neutrons. So if proton stays the same, but your mass is what's different, then that means our neutrons are what are different in isotopes. So atoms of the same element that have different masses and therefore have different numbers of neutrons. So we can write this in a specific way. There's kind of a convention notation for writing isotopes. So the first is super simple. It's just writing the name and the mass number. So just like I wrote on the previous slide, carbon-13 is carbon with a mass of 13. So that number at the end there is the mass. We can also write it as more of a almost formula looking thing. So this is the generic version of that here. So the top number is going to be your mass number, protons plus neutrons. And the bottom number here is your number of protons. So Z is your number of protons. Sometimes that number will be omitted because you can list the symbol. And remember, your symbol and your number of protons are both telling you exactly what element you're talking about. If you were to look for Cu on the periodic table, you would find that it's number 29. So it's almost a little bit redundant, so you may see that omitted when you look at problems or on your final exam or something like that. But it's always the bigger number over the smaller number, so mass, and then atomic number, and then the element symbol. The other thing you might be missing is there might be a charge listed in the top right. It's always listed as a superscript. Let's say this one is +2 in that case. So it will always be listed as a superscript in the upper right of this symbol. We can summarize this information in a table that looks like this, and this is what you'll see on your assignment sheet. So I'm going to go through 2 examples of this so that we can know how to fill it in. So it's kind of like a little bit of a puzzle where you don't have to fill it in left to right order necessarily. You're just going to use what you're given in order to fill in what you can. So looking at this first one, it says that the element is helium. And so I'm going to look for helium on the periodic table because that's where I can find its atomic number. So helium is number 2, so its atomic number is 2. We also know that our atomic number is the same as the number of protons. So those columns should always match in a table like this. Your atomic number is your number of protons. Next, I'm going to look at what the other information I have. So I'm also given that the mass number here is 4. And if we remember, your mass is equal to protons plus neutrons. So my mass is 4. I have 2 protons. And so how many neutrons do I have? Well, 2 plus 2 is 4. Okay, and then the last one, electrons here. Electrons, for the most part, are going to match your number of protons. So unless otherwise stated, electrons and protons will also match. I'm going to go over an example where they don't next. Lastly, we're going to put that all together and summarize that in our isotope symbol, where we put our mass of 4, our atomic number of 2, and then the symbol from the periodic table, He. The next example we're going to look at is a little bit different. So the first part is going to be the same. So I'm going to kind of cruise through that. So our mass number, according to the symbol that I'm given here, 40. The atomic number is 20 based on that convention for our isotope symbol. It also means our number of protons is 20. In this case, our number of neutrons is also 20 because 20 plus 20 will give me that mass of 40. And I know that I'm dealing with the element of calcium. And we'll squeeze for room there. Okay, the difference here is that we do have this charge. And so when we have an atom with a charge, it's called an ion. And what we need to think about is normally in an atom, we have our positively charged protons and we have negatively charged electrons. So only 2 particles have those charges. Now, normally those are going to even each other out or balance each other out so that there's no leftover charge. But when I have this charge written here like this +2, that means I do have leftover charge. So how did that happen? Well, this charge tells me that I have 2 positively charged things that aren't being balanced out. So if I add 2 protons, that would definitely give me 2 things that are positively charged that aren't being canceled out. But then we'd have a problem. That would mean I would have 22 protons, and then we're not talking about calcium anymore. So I can't do that. So it turns out that the only thing that you can actually manipulate when you're talking about charge is your number of electrons. And so we can either gain or lose electrons. And so if we have a positive charge here, that means that we have extra protons that aren't being balanced out. And so that would mean a loss of electrons. And in this case, that would mean a loss of 2 electrons. And so our number of electrons, instead of being 20, would be 18. Okay, the other way you can think about it, and I do encourage you to definitely think about it conceptually in terms of those charged pieces, but the other way you can think about it is that since electrons have a negative charge, whatever the charge says, you do the opposite. So since this says +2, we're going to take away 2 electrons, okay? Or if it said -2, you would add 2 electrons. either way, it doesn't matter how you think about it, but I do want to make sure that you see an example of that before your assignment sheet. So you guys can get started on that tonight, and we'll talk more about this in class.